All right, so this is Mr. Sadler,
Mr. Johnson.
and today we're going to talk about Section 3, and we're going to talk about Newton's second law. Okay, so do you want to go ahead and read the actual definition for Newton's law?
Sure. Basically, it says the acceleration of an object is directly proportional to the unbalanced force acting on it and inversely proportional to the object's mass. Now, that's quite a mouthful. Here's an easier way to remember it. F equals ma.
And F stands for?
Force, and m is mass, and a is acceleration. So we have mass, acceleration.
Okay, and maybe we want to talk about units here. So what is the units for force? What is
Okay.
the units for mass? And what is the units for acceleration?
Well, we know mass, it's the kilogram, and we know acceleration is meter per second squared.
Okay.
Now, since we're multiplying both of those together, the unit for force is simply kilogram times meter per second square, or to honor the person who came up with this law, we call it a Newton. Capital N, which is the same as saying kilogram times meter per second squared.
So this is all in SI units, and this is one of the reasons that we use SI units. It's so much easier. Okay, so
Now, one of the things you notice is you have force, mass, and acceleration. It's multiple variables. Just like we did with the velocity one, you can actually make that nice little circled device, split it up, and put the units where they belong. Oh, sorry.
that's okay. Just
So whatever one you cover up is the one that you're actually going to solve for. So if we actually covered up force, it would be m times a. So if we cover up acceleration, you would actually have a is equal to force divided by mass.
okay, and really I think what we want to get to here is in the investigate that we did today that a force, a constant force on something equals what?
Constant acceleration.
Correct. So it's a little bit difficult to understand that sometimes for students, okay? But if we were in outer space again with no friction, if you constantly shoot a rocket, okay, in one direction, you get constant acceleration. You don't get constant velocity.
Right, because there's nothing actually preventing you from slowing down. It
Correct.
just keeps going faster and faster and faster.
Correct. All right, so let's go ahead and work one of these problems.
Okay.
F equals ma problem.
All right. So let's say we have an object.
Let's say that's 10
kilograms.
10 kilograms.
So we have an object that has a mass of 10 kilograms, and it's accelerating at a speed of 5 meters per second squared.
Okay, so now we have a force, and we're going to calculate the force with a mass and an acceleration.
So the force is equal to 10 kilograms times 5 meters per second squared. And if you need your calculator, you should be in trouble. It's 50 kilogram times meter per second squared, or
50 newtons.
50 newtons. Just
Okay.
like that. Now you're saying, hey, that's an easy one. Yeah, it is, but now what if we want to know the acceleration of an object? So what we would do is, say you have a force of an object.
Well, you can show that diagram again and manipulate the
It's a good call.
so force on top, mass and acceleration. And when I put my finger over acceleration, I've got so acceleration equals force over mass.
And we'll show you how the actual units come into play as well. So let's say we have an object with the mass of, 100 kilograms. All right, and it has a force acting upon it, say, 1,000 newtons?
Okay.
Okay. So a force of 1,000 newtons. So now we want to know what the acceleration is, so we actually put it into the formula. So you have 1,000 newtons, and then in parentheses, I'm actually going to put the units that a newton is, just to show you where we get it.
Divided by
The actual
100.
100 kilograms. This is where it's important to actually use your units. We've been telling you that in class, because now you have to manipulate them. Kilograms are going to cancel, and you're left with meters per second squared, which is the unit for acceleration.
Correct.
So now, again, you should be able to do this in your head and not need your calculator. You get an acceleration of 10 meters per second squared.
Correct. So we've done a couple of problems, and force, again, Newton's second law is force equals mass times acceleration. Signing off, this is Mr. Sadler.
And Mr. Johnson.